Awesome. All right. All right. Thanks for coming, everyone. Sorry we were a little bit slow. It's our first time at this spot. I hope you like it. I think it's pretty big upgrade. We've got way more space. We've got uh, plenty of desks so everyone can spread out. Um, so we'll be talking today about the computer vision series that we're starting. So we've done several book series in the past. So this is just the beginning of a new one. It's going to last a decent amount of time, and we're going to push the pace a little bit just so it doesn't stretch out to a year plus. So I'll just start us off just kind of walking through what the expectations are, and then Ted will give us a little overview of um, the first chapter. So the goal for today, mostly just social, get everyone acquainted with what the format will be and everything. I'll discuss the format a little bit. I'll say what the expectations are, and then Ted will go through chapter one. Um, so just as far as the format, please, if you have the time, try to read the chapters, try to run the notebooks. That hopes you're learning a ton. So we only have limited time here. We can't teach you the entire chapter in an hour necessarily. So if you can run it or even just make an attempt, you don't have to. Some of the chapters are long. It helps a lot if you at least get some grounding in what the chapter was about. Then we can come and fill in the blanks because the goal isn't necessarily teach you computer vision end to end 1 hour at a time. It's to maybe help you with the parts that you struggle with when we're here, and then when you're home you can do some studying and get started on everything. So it's very important, like bring questions. That's the highest value thing you can do is, I went through this, I read this technique, it doesn't make sense. If you bring that and we discuss it, it helps you get your question solved, but a bunch of other people probably also had the same um, question. And we often find that even if you thought you knew something, when we actually dig into the details, it makes you realize, oh, I didn't understand this piece, I didn't understand that piece, and you get deeper on the details. And so it helps everyone if you bring questions. Um, so just some tips while you're going through the notebooks or the chapters. Try your best to understand things, but don't stress out. Like the whole point is to come here, bring questions, and then learn from each other. So my kind of rule of thumb is like, do a first read, do a second read. If it doesn't connect on the third read, just write a question down and bring it. So don't try and solve the entire thing by yourself. Like that's the reason that we're here, is to kind of cover some of those things. And so one of the things that I find very useful when doing these things is they might say, here's how you solve some self-driving car thing, and you don't care about self-driving cars. Try to think about any of the techniques that are shown and then apply it to, like, if you're in bio or if you're in banking or if you're in something else, like try to transfer it to whatever your domain is, and then it will stick much better by being something that you actually care about versus some random example that you're not invested in. Take notes, bring questions, be social. I think that's a big part of this. Like many people have met other people here, and then they've gotten jobs or they've worked on projects together, and they've learned a lot. And I think a lot of the value here isn't necessarily the technical content. It's having someone next to you that holds you accountable, and okay, I made a friend last week and I want to go hang out with them again, and that pushes you to learn a little bit every week. So I think that's very valuable to just be social. Um, so one thing that I encourage people to do is join the Slack. We have a Slack channel that has a whole bunch of people in it, and it's not particularly active. So if you guys can help with that, that would be great. So we have a ML Book Club channel, and if you want to go in there and just introduce yourself, that would be really appreciated. Just tell us, where are you from? Are you local to San Diego? Did you travel here? Are you online in Africa? Like we've had people visit from all over. So show off where you're from. Tell us what kind of problems you're interested in. You might find other people that are interested in similar problems to you, and then you can work along with them. Are you a student? Are you working? Add anything you want to your introduction, but I highly recommend that people go write something about yourself, and it might turn out valuable to you. Um, as far as intro, um, that's all I've got. One thing I do want to show is we have this sort of loose timeline of how things we expect to go. So first week, Ted's just doing the intro, and then after that, I'll be covering some of the workshops. So we're kind of interlacing a set the book and a set of notebook tutorials, and so Ted will be covering the book, and then me and Anastasia will be covering some of the notebooks, and so we can walk you through code and we can learn the actual technical details. In the book we'll cover more of the theory. um yeah, I think that's all I've got. I will hand it off to Ted then. Yeah, go for it. I've well, the origin of this whole meetup group was we just got together and we did Kaggle competitions. Um, and so I originally learned machine learning through other people at meetups, and so part of the motivation is like giving back, but also it's partially just a forcing function for me and Ted. Like if we say we're going to teach this computer vision thing, then we get forced to go read a book. So it's kind of dual purpose there.
Yeah, and I'll add my 2 cents. I'm a big believer in ML fundamentals. Uh, I might be doing like whatever, a CNN deep learning, and so it really isn't going to use directly any of the stuff you learned in like your first course on um, linear regression and stuff. But I do find that ultimately there's a depth around like uh, understanding your loss function, right? Are we using mean squared error loss? Are we using cross entropy? And why is cross entropy? And if you use something slightly different, understanding that like focal loss is actually moving you away from the um, the MLE, maximum and things like that. So um, in this case, I definitely do not know all this computer vision stuff. So a lot of this is going to be very new for me. But even when we do a book where I feel like I know 80 or 90%, I just find that my depth of understanding definitely gets improved by going through this stuff. So, yes, part of it is giving back, but part of it also is just selfishly, it's not just a forcing function for me to read the book, but I get it at a much deeper level. All right, so let me try and share my screen here. All right, is that working? Cool. Oh, this guy. All right. So thanks. Ryan covered a lot of the basics, and I'm going to slightly repeat one of the things he talked about. So um, I talked to some people about computer vision several months ago while we were still doing the math for machine learning book and did a little bit of a search. And it seemed like this Gillespie book is really highly rated, and a lot of people like it. But then as we got closer to actually doing this, I'm actually really thankful. Some people said, well, like that's not very hands on. Is there something we can do that maybe has some stuff that's more hands on? And this book's not old, but in the last 2 years, things have changed a lot, right? So, so with that really great feedback, ultimately did a search, found a really nice series that's online, and so I'll show it in a second. But so the plan now is we're going to mix this Siliski textbook and this online material where the slides and other materials are in the repo on GitHub, and then uh, he has recorded YouTube videos for a lot of the content. So depending on sort of what modality, how you learn best, whatnot. Um, we're probably not going to exactly cover the book. We're probably going to go in sequence, but we're not necessarily going to cover it exactly as the book is. We're not necessarily going to cover the online series either exactly as is. And by combining the two, one of the things that we're going to bump into is they're not going to be perfectly synchronized. So what's going to happen is the hands-on in terms of like how advanced the models are and things like that, it's going to ramp up much, much, much faster. It's still going to start with the basics, practically assuming you almost, barely even know any Python. Okay. So it does start like at a very good entry level. And it won't be going into the details about what is this model, how does it work, any of that stuff early on. But you will actually be able to be doing something interesting where you're like, hey, I'm actually classifying thing, I'm actually whatever, segmenting something, or tracking an object, or something like that. But just want to say up front, a function of merging this is that it's going to take us into like 4 chapters through the book before it actually introduces neural networks. And, we'll start talking about neural networks the first or the second workshop, right? Um, in terms of like level setting, I think pretty much anybody here who has done any ML, if you've trained a linear regression model, then you have everything it takes in order to participate in this series. So it's pretty beginner friendly. And then for me, I feel like I'm fairly senior with the ML, but I've never actually taken a computer vision class. So I probably know more about some of the more advanced models that have come out in the last 2 years than I actually know about stuff that's 50 years old, you know. Um, yeah, so I think that's the preliminaries. Just wanted to share a little about that. Um, we're going to test out the pacing. The pacing is intentionally going to be a little bit fast. It's whatever 14 chapters in the book, and 16 works or 13 workshops or something currently defined. And if we do one of those every other week, you do the math, how long it's going to take. So we're going to kind of look to see, can we do one workshop a week? Can we do 2 workshops a week? What's the pacing going to be? And then depending on who you are, the textbook weeks might be the heavy weeks for you because reading is like something that takes you a lot longer. On the other hand, for somebody else, it might be that the workshop weeks are a little bit heavier for them because you're not as used to, playing with Python, Jupyter notebooks, and whatever. And maybe you step through the code a little slower. So we'll just see how it goes. But I would say high level, kind of echoing some of Ryan's comments, there's um, there's 2 things that I think you can get out of participating in the book club. So one is, if reading it on your own, you're someone who might possibly relate to, I stopped after chapter 8 and never actually made my way all the way through the book. Okay. Then we're doing this together. This is something to like help, motivate you and just like have that support to like, yes, we're going to make it all the way through the book. Okay. But the other way that you can use it is like Ryan said, is to go a little bit deeper. So if you have trouble understanding some of the concepts, yeah, you can come and ask a question. If you're actually doing computer vision and you're pretty sophisticated, feel free to ask a question about like, this concept in the book is just talking about this at a very shallow level, but isn't this like what was the difference between BYOL and SimCLR? And like we can, have the people in the room who have more experience go into those like deeper kinds of things as well. So I personally think it's okay. There'll be mixed levels. When I first started coming to meetups, there's a lot of things people were talking about that went over my head. I didn't understand, but I still got value from, a good chunk of it. All right. So that's a bunch of preliminaries. I want to dive into the book. I don't think it's super critical. Chapter 1, I'll share a little bit about from the book, but it, there was no expectation that you guys necessarily read in advance. The hope is for next week, you will actually take a look at the slides, the Jupyter notebooks, the videos, some combination of those prior to the meetup. If you feel like, wow, that was actually like really a cakewalk for me, then one possibility is in 2 weeks when you come, you can be someone that's actually helping answer questions for some of the other people that maybe weren't as familiar with it. But I will certainly be over the course of this series, I'll definitely be running into a lot of material that's new to me. All right. So chapter 1 talks about what is computer vision, and I'm not going to go into the details, but for me, when you look at the perspective of this Zalewski book, my introduction to computer vision was much, much later, much more recent. And so if you look at like Medium blog posts, what is computer vision, right? They're probably going to say classification, object detection, segmentation. And then, depending on which post, then they might list a few more things like depth estimation, pose, and these are things that are all today done with deep learning. And that's what I think of as, I don't even know what, like 2020's definition of computer vision. But if you go back and you look, there's older stuff. So there were people who at one time thought that OCRing, a scanned page of text, that was computer vision. Okay. Exposure bracketing for a photo, just to say like, hey, I took this picture and there's this part that's in the sun and this part in the shade, and how can we clean this up? That's been considered computer vision, right? All the stuff that Hollywood does. Okay. So CGI, blending of things, morphing, 3D animation. So I don't think there's any one right definition of computer vision. This textbook is going to do a lot more grounding in the principles. So next session is going to be a workshop session. The session after that's going to be chapter 2 of the book, and it's going to start with how does light travel, and it's going to talk about I can't even say it, but those kinds of concepts. And so the idea of you have some type of camera, whether it's your eye or a digital camera or whatever, and you may have a lens. And I've never been a photographer, right? I've heard of f-stops. I don't actually know what that is, but it's going to be at least a sentence or a paragraph in the chapter. Okay. So it's going to take a little bit more event. And so we'll see a little bit more in the textbook on things like structure from motion, or slam. I don't think it's necessarily going to go heavy, but like Kalman filters, so some of that stuff, the workshoppy stuff, is pretty much 100% deep learning. So I think in the end it'll be a pretty good mix. Any questions? Oh, okay. All right. So then there's this chapter, section in the chapter on the history of computer vision. Most of this stuff is very new to me, so I can't comment too much on it. I thought about preparing more. In the end, things are very busy. I have a very full house with a lot of guests, and so I didn't really prepare that much on this, but I thought it was interesting. Here's this timeline. So this book was published in late 2021. So like December or something like that. And so 21, 22, that's sort of the time cutoff. If you're familiar, like DALL-E as an image generation model existed at that time, but no stable diffusion, and some of these, newer things, right? So what I wanted to highlight is Richard Zalewski has this timeline, and then in the next few pages he goes through things. And deep learning is this second to last item here, way, way, way on the right. Okay, so just know that even the chapters that talk about, say, like pose estimation that will include deep learning are also going to include material for what came before. And this is, again, one of those things where it's like, well, I'm not sure. Maybe I will wind up using some of this stuff. I do actually use computer vision at work. But maybe what'll happen is it'll just really deepen my understanding of what's going on, the strengths and the weaknesses, even if I end up exclusively just using, you know, big deep learning networks. So a little bit of the history here. I have the photos, the figures from this history section. Okay, so it starts with saying, hey, in the 70s, there's this idea of you can do edge detection, and there's some like different algorithms, and one of the big things is if you look at this, the amount of compute that was available in that kind of a time frame, it was really paltry, and so part of it is the sophistication of people, and part of it is even if they had this idea in their mind, if it was something that would be very compute intensive, it would have just been a laughable idea that nobody would be trying back then. Okay, and so then we go decade by decade. um, we get here to the 1980s, and so this uh, top image here, A, was a blended image. So we had a red apple and we had a something else, and we blended them. And in the 1980s, this is pretty high tech. This is pretty cool. This is an apple that does not exist. Okay, that was like the 1980s version of that, right? And some techniques that I am not familiar with here. If you look in the caption, right, it's talking about pyramid blending, physically based models. I don't know what regulation based surface reconstruction. Not things that, to my knowledge, we really recognize that are common today. Fast forward to the 90s, it's starting to look a little bit more familiar to me. You see this first item in the figure, factorization based structure for motion. Okay, so I don't know how different this is from I think the batteries on that mic died. All right. Can somebody give me a thumbs up if you can hear now? Okay. Awesome. Sorry about that. Um and then the big trend that paired with more computing is we started to see, because of more computing power being available, people proactively working on larger data sets. So this idea of ImageNet, Coco, that these larger data sets would allow people to start tackling this and measuring these things at larger scale. And so then ultimately the last slide I have here is 2010s and forward. Um, this first picture, it's a crop. I don't know if you can tell, but this is from the schematic, the architecture for AlexNet. Okay. So, for me, I think of 2012 AlexNet as certainly the deep learning watershed moment for computer vision. Also, people talk about sort of the ImageNet moment in terms of computer vision. So it was interesting to see them talking not just about the fact that we have GPUs. It's kind of interesting if you think about it, was GPUs existed, but one of the things in the AlexNet paper was how to use a GPU not for computer graphics, but for these matrix multiplies that I want to do. And so I have to always kind of remember that, because I take it for granted that if yes, I know you can play games, really cool, games with my GPU. But if I buy a consumer GPU, I just assume, yeah, of course I'm going to do matrix multiplies. And I guess there was no CUDA, so you had to actually be a little bit more scrappy if you actually wanted to use it just for, your matrix multiplies instead of for gaming. And so we're going to start to see, hopefully, I have not read the Zaliski textbook before, but really this blend of a lot of these founding principles, this grounding before we get to deep learning. And then for me, a lot of times deep learning, it's a little bit like, well, there's this black box we don't really know. For CNNs, I feel like I have a mental model. I'm not sure how 100% accurate it is, but it's like, okay, we detect edges. And so if you combine vertical edges and horizontal edges and blah, 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 you can then have triangles and circles and things. and you can detect textures. And so if you say, if I see this texture and I see two round things that look like an eye and a thing that looks like a nose and a thing that looks like a mouth, you know, um, but for a lot of these other models, I don't necessarily have some of that more fundamental. All right, so that's just like a really quick preview. Um, I guess that was my last slide. I thought I had another one, but um, yeah. So again, today very light in terms of content. I'm hoping that I know here physically in the room, while we were trying to figure out the logistics and get everything set up, a bunch of people were able to just say hi and meet other people. One of the things I wanted to do was to also create some breakout rooms. And so for those of you who are online, give you a chance just to meet some other people. So unless there are um, other questions, my plan is to talk specifically a little about next week's uh, uh, topic. No, sorry, not next week, next session. So it's going to be in 2 weeks. The topic, and then have things be a little more social. Question? Yeah. All right. So logistically, the if you want to know kind of what's going on with this series, the place to go is to our book club repo on GitHub. Okay. There are links to this repo from every meetup event. There's links, I think, like all over the place. So hopefully you won't have any trouble finding it. If you really do, just ask on Slack. Um, so we have a new page for the computer vision series. It has links to the book. If you haven't bought the book, you can buy the physical book. You can go to Richard Salisky's website, and there's a form you can fill out and get a free copy of the PDF version of the book. Links to the YouTube playlist, links to the GitHub repo for the practical computer vision course. So all this stuff is here. If we learn about new cool materials, if somebody says, "Hey, I found this really awesome, supplement where somebody did additional videos about this textbook or something like that," we'll go ahead and we'll add it here. And then the other main thing is the schedule. So right now, we're very tentative in terms of what's the right pacing. So so sometimes when we're more confident, we might have tentative sessions mapped out through the end of the book. I purposely just didn't even do that because that would be what's the term, false precision. Make it look like we actually know what the plan is. But so I've got about 5 sessions or so of each the book and the workshops, and we're going to see, is this too fast? Is are we going to try to go even faster? Again, not to go fast like crazy, just to make it super intense. But part of the benefit is, we would like to finish before December 2026. So there's that. So yes, you can always see the upcoming schedule here. This does not have, I did not go crazy, but so for example, if it says session 2 is workshop 1 and workshop 2, they're not links. You have to actually go, yourself to the YouTube playlist, and then you can say, okay, here's workshop 1, here's workshop 2. Another note is if you go to the repo, the book is pretty straightforward. It's a chapter. If you go to the repo, there's other stuff in the repo. I have not looked at everything that's in here. But you can see down here, he's got a sort of a tutorial schedule, and he's got some links. You can open the notebooks and like collab and stuff. But then also when I was just sort of navigating things, it's like, oh, okay, it's kind of buried. It's slides, practical computer vision series, and then here's all the PDFs for all the weeks. So just wanted to kind of show you that in terms of like basic navigation. There are also in the textbook, there are exercises at the end of individual chapters, and I have not yet waded far enough in to see how much value there is. And so it's possible that if people read chapter 2 and they're like, hey, I don't really have any questions, then maybe we'll spend some time talking about the exercises. Final note, some of the chapters, like I think chapter 2 is quite long. It's a little bit a little bit like a reference book as opposed to a textbook, even though it is. Um, so all the more reason I will argue for you to come with questions, because for time purposes, we literally might not cover the entire chapter two. If four people have questions about different parts, we might talk about those four parts, and we won't talk about the other parts of the chapter unless somebody has a question, just just for time purposes. For shorter chapters, we can kind of do that. Um and so this is a model which I'll honestly say we've talked about, have not necessarily actually successfully done with books in the past. But more and more, we're hoping for it to be question driven versus like, okay, let me just talk about section one. Let me talk about section two, section three, which is more like what I just did now with chapter one, right? So hopefully, the future chapters look more interactive and um, less like a lecture or something like that. All right. Anything else? All right. Let me just check my Zoom chat real quick. Yeah, I see a hand raised online. If we did the AV right, we can actually hear you. Feel free to unmute and ask your question.
Yeah, thanks, Ted. I just want to know whether we need to find a GPU to run this workshop.
Uh, I have not gone through all the workshops. My understanding is you will be able to play with them a little bit without a personal GPU. So just like free Google Colab should be plenty. Um, it's crazy because there was a time, maybe what, 3 years ago? I don't know the exact date, but like when we kind of talked about how big and how expensive some of these models are. Now that we have LLMs, they like seem very quaint. It's like, ooh, this model's 200 million parameters. And so that's like the smallest GPU we have. Not only can you do inference on it, but you can even do fine tuning, you can do training, and it's like nothing, compared to even, a small Llama 7B or something like that. And then the issue with the LLMs is that it's not just how many parameters they have, but the activations grow with sequence length. So you have whatever parameters, but you have 4,000 tokens coming in, and then the amount of memory you need for activations is times 4,000. Whereas you don't have that with computer vision models in general. So I haven't gone through everything, but I will be pretty much shocked if on like a Google collab with a free, I don't even know what they have these days, T4s, P100s, whatever, you probably can just do everything for the whole series. It's a great question.
Yeah, thank you.
Thanks. All right. So if there's no other questions, then what I'm going to do is I'm going to open up some breakout rooms for the people on Zoom, and I'll target like 5, 6 people per room. Some people may have time, they may need to drop. But then you can meet a few other people who are going to be on this journey with us. And then for people here, eat more pizza and meet some more people. All right. Thanks, everyone.